important questions on Tiwari's theorem. So first question is, prove that 1 plus cos theta plus I sin theta upon 1 plus cos theta minus I sin theta whole power n is equal to cos n theta plus I sin n theta. Okay, as we know, Tiwari's theorem is that cos theta plus I sin theta. Tiwari's theorem is that cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. But here we need to show 1 plus cos theta plus I sin theta upon 1 plus cos theta minus I sin theta whole to the power n is equal to this thing. Okay, so how we prove? So proof is very easy. Left hand side is equal to 1 plus cos theta plus I sin theta upon 1 plus cos theta minus I sin theta whole to the power n. Okay, now there are so many techniques to prove this thing, but I am going to solve by very simple technique. In trigonometry, we have value of 1 means cos square theta plus sin square theta is equal to 1. Means in place of 1, we will write cos square theta plus sin square theta. Also, our aim is to connect in iota form, means in complex form. So we can write also cos square theta minus I square sin square theta is equal to 1, since I square is equal to minus 1. Okay, so this should be here cos square theta plus sin square theta, or cos square theta minus I square sin square theta. So here cos square theta minus I square sin square theta in place of 1 plus cos theta plus I sin theta. In denominator, same thing. This is as it is, 1 plus cos theta minus I sin theta. If you want to write here, so you put this thing as it is in numerator. So we will put in numerator or denominator in place of 1 to the power n. Now a square minus b square is equal to a minus b, a plus b. A square minus b square is equal to a minus b, a plus b. By using this formula, we will write cos theta minus I sin theta into cos theta plus I sin theta, and this thing as it is, plus I sin plus cos theta plus I sin theta upon denominator as it is, means 1 plus cos theta minus I sin theta whole to the power n. Okay, now here there are two terms, so cos theta plus I sin theta is common in numerator, so we will write here is equal to cos theta plus I sin theta is common. So here this is cos theta minus I sin theta, cos theta minus I sin theta, and here plus 1 upon 1 plus cos theta minus I sin theta whole to the power n. Now this is same thing, cos theta minus I sin theta plus 1, and this is same thing, so this cancelled. So this is equal to cos theta plus I sin theta to the power n. Now by de Moivre's theorem we have cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta, and hence proved. Now the second very important question, 1 plus sin phi plus I cos phi upon 1 plus sin phi minus I cos phi to the power n is equal to cos n pi by 2 minus n phi minus I sin n pi by 2 minus n phi. Okay, so prove. So left hand side, 1 plus sin phi plus I cos phi upon 1 plus sin phi minus I cos phi to the power n. Here we remember that de Moivre's theorem applied when this is real part and this is imaginary, means we have by de Moivre's theorem cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. It means we apply de Moivre's theorem when real part is cos theta and coefficient of phi is sin theta, but here real part is sin phi, means this is not cos phi, here coefficient of phi is cos. So our aim is to convert this sin into cos and this cos into sin. So we have sin phi is equal to cos pi by 2 minus phi, and cos phi is equal to sin 90 and pi by 2 minus phi. It means this will reduce in de Moivre's theorem. So this can be written as 1 plus cos pi by 2 minus phi plus I sin pi by 2 minus phi, okay, upon 1 plus cos pi by 2 minus phi plus I sin pi by 2 minus phi. This is n. Okay, now this is in terms of this form, means coefficient of I is sin theta. So here coefficient of I is sin theta. Now in the first question we have proved 1 plus cos theta plus I sin theta upon 1 plus cos theta minus I sin theta to the power n is equal to this thing. Okay, so this is the same question, means if we put this pi by 2 minus phi, this pi by 2 minus phi is theta, this pi by 2 minus phi is theta, this is theta. So this question is 1 plus cos theta plus I sin theta upon 1 plus cos theta plus I sin theta. Here minus, here minus. So this is the same question. Okay, means this is the same question. 1 plus cos theta plus I sin theta upon 1 plus cos theta minus I sin theta. Okay, means if we put this place is theta, here theta, here theta, theta. So this is already reduces in the form cos n theta plus I sin n theta, where theta is equal to pi by 2 minus phi. Okay, so by putting the value of theta, this is equal to cos n pi by 2 minus phi plus I sin n pi by 2 minus phi, and hence proved. Okay, this is next very important question. If xr is equal to cos pi upon 2 to the power r plus I sin pi upon 2 to the power r, then prove that x1, x2, x3 up to infinite equal to minus 1. Here x1 means if we put r is equal to 1, so x1, r is equal to 2, x2 up to r is equal to infinite, means number of terms are infinite, and product of all the terms is equal to minus 1. This question has been taken by the book, this book, Algebra and Trigonometry. Okay, so now we shall prove. So first x1. What is x1? x1 is equal to cos pi upon 2 to the power 1 plus I sin pi upon 2 to the power n. x2 is equal to cos pi upon 2 to the power 2 plus I sin pi upon 2 to the power 2. This is very easy. Only putting in place of r 1, 2, 3 up to so on. So similarly x3 is equal to cos pi upon 2 3 power 3 plus I sin pi upon 2 to the power 3. Now similarly we can write another term. Okay, now we need multiplication of each terms. So x1, x2, x3 up to infinite means product of right hand side. So cos pi upon 2 plus I sin pi upon 2. Next product cos pi upon 2 square plus I sin pi upon 2 square into next in the multiplication cos pi upon 2 cube plus I sin pi upon 2 cube in the product up to infinite. Okay, so we have, when we have proved the De Moivre's theorem, then we have means cos theta 1 plus I, cos theta 1 plus I sin theta 1, cos theta 2 plus I sin theta 2, and similarly cos theta 3 plus I sin theta 3 up to cos theta n plus I sin theta n. So in this case angle will add, means cos theta 1 plus theta 2, if we have cos theta n plus I sine theta n. So theta 1 plus theta 2 plus theta n plus I sine theta 1 plus theta 2 plus theta n. It means in the case of product cos theta plus I sine theta, so there are n product. So all the angle have adding, all the angles will add, means theta 1 plus theta 2 plus theta n. So similarly here there are number of factor are infinite, so here all the angle will add. Okay, it means this will equal this equal to cos, first angle is pi by 2, second pi by 2 square, third pi by 2 cube up to infinite. So pi by 2 plus pi by 2 square plus pi by 2 cube plus up to infinite. Okay, similarly plus I sine, same thing in the case of sine, means pi by 2 plus pi by 2 square plus pi by 2 cube up to infinite. So this term means in the bracket, in the both term, these are same. Okay, so our aim is to solve this thing. So this is same. So since pi by 2 plus pi by 2 square plus pi by 2 cube up to infinite, here if we take common pi by 2, so this is equal to 1 plus 1 by 2 plus 1 by 2 square plus infinite. Okay, so this is a geometric progression. Okay, this is geometric progression, means this equal to pi by 2 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube up to infinite. So in geometric progression we have sum of infinite term, means in geometric progression a plus ar plus ar square plus up to infinite. So sum of infinite term, s infinity, in case of geometric progression we have s infinity is equal to a upon 1 minus r. A is first term, r is common ratio. So here is equal to pi by 2, first term is 1 and common ratio is 1 by 2. So 1 upon 1 minus 1 by 2. So this is equal to pi by 2, 1 minus 1 by 2, 1 by 2. So 2 in numerator, this thing 2 to cancel, so this is pi. Okay, it means the value of pi by 2, 1 plus 1 by 2 plus 1 by 2 square up to infinite, this is equal to pi. Okay, it means the value of cos this thing pi plus I sine pi. Okay, so now our x1, therefore x1 dot x2 dot x3 up to infinite is equal to cos pi plus I sine pi. Since cos pi is equal to minus 1 and sine pi is equal to 0, so this is minus 1 plus I into 0. Since cos pi is equal to minus 1 and sine phi is equal to 0, so this is equal to minus 1 and hence proved. Next very important question, if x plus 1 upon x is equal to 2 cos theta, y plus 1 upon y is equal to 2 cos phi, then prove that x to the power m, y to the power n plus 1 upon x to the power m y to the power n is equal to 2 cos m theta plus n phi. Okay, so proof. Given x plus 1 upon x is equal to 2 cos theta, and similarly y plus 1 upon y is equal to 2 cos phi. It means in place of x is y and in place of theta is phi. So only we need to solve x plus 1 upon x is equal to 2 cos theta. And similarly, we can put in place of x is equal to y and in place of theta is equal to phi. Okay, so now this is on multiplying by x. So this is x square plus 1 is equal to 2x cos theta. This is quadratic in x. It means we can write x square minus 2x cos theta plus 1 is equal to 0. So this is very easy because this is quadratic equation in x. So by Sridharacharya method, x is equal to means ax square plus bx plus c equal to 0. So this is very easy. X is equal to minus b plus minus b square minus 4ac upon 2a. So here this is b. So x is equal to minus b. So 2 cos theta plus minus b square. B square means 4 cos square theta minus b square minus 4ac. So minus 4 upon 2a. So 2. Here a is equal to 1. Now 2 cos theta plus minus 4 is common. So 2, because this is square root. So cos square theta minus 1 upon 2. Here 2 is cancelled. Now since 1 minus cos square theta is equal to sin square theta, but here cos square theta minus 1, it means we take common minus 1, means minus 1 minus cos square theta is equal to cos square theta minus 1. So this is equal to cos theta plus minus, this is minus cos square theta minus 1 is equal to minus 1 minus cos square theta, 1 minus cos square theta. Okay, now 1 minus cos square theta is equal to sin square theta here. So this is cos theta plus minus, due to minus sign, this is I sin theta. Okay, it means cos theta is equal to, x is equal to cos theta plus I sin theta. So there are plus or minus. So we can take either plus sign or minus sign. So on taking plus sign, so x is equal to cos theta plus I sin theta. Okay, our aim is to calculate x to the power m. Okay, so x to the power m is equal to cos theta plus I sin theta to the power m. Now by de Moivre's theorem, our de Moivre's theorem is that cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. Okay, so this is equal to cos m theta plus I sin m theta. And similarly, this is x to the power m. Similarly, y to the power n. So What is y? So y is nothing but y plus 1 upon y is equal to 2 cos phi. So similarly, y square plus 1 is equal to 2y cos phi. So we can solve very easy, means y is equal to cos phi plus I sin phi. Okay, so y to the power n is equal to cos phi plus I sin phi to the power n. Now, by De Moivre's theorem, this is equal to cos n phi plus I sin n phi. Okay, by De Moivre's theorem. So now, x to the power m, y to the power n, this is equal to value of x to the power m cos m theta plus I sin m theta into cos n phi plus I sin n phi. So as we know, by using De Moivre's theorem, when we have proved De Moivre's theorem, then we saw that angle has used angles as sum, means cos theta 1 plus I sin theta 1 cos theta 2 plus I sin theta 2 is equal to cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. Okay, so this is equal to cos m theta plus n phi plus I sin m theta plus n phi. Okay, now we need to calculate 1 upon x to the power m, y to the power n. So since x to the power m, y to the power n is equal to this thing, so this is x to the power minus m, y to the power minus n. So in place of m and n is minus m and minus 1. So only we put in place of m is minus m and in place of n is minus n. So 1 upon x to the power m, y to the power n is equal to cos minus m theta minus n phi plus I sin minus m theta minus n phi. This is very easy. Only we put in place of m is minus m, in place of n is minus n. Okay, since x to the power m, y to the power n is equal to this thing. So x to the power minus m, y to the power minus n, only we put m is equal to minus m, n is equal to minus n. Okay, so now this is equal to cos minus common, so minus m theta plus n phi, this plus I sin minus m theta plus n phi. Since cos minus theta is equal to cos theta and sin minus theta is equal to minus sin theta. Okay, so this equal to cos m theta plus n phi, here minus I sin m theta plus n phi. So this is the value of 1 upon x to the power n, y to the power 1 upon y to the power n. Okay, so by adding x to the power m, y to the power n and 1 upon x to the power n, y to the power n, means here x to the power m, y to the power n this thing and 1 upon x to the power m, y to the power n this thing. Okay, so this is equal to x to the power m y to the power n plus 1 upon x to the power m y to the power n. This is equal to, so this is x to the power n y to the power n. This is equal to cos m theta plus n phi plus I sin m theta plus n phi, and plus the value of this thing is only change here, minus sign, means cos m theta plus n phi minus I sin m theta plus n phi. So this is positive, this is negative, this will cancel, and this is equal to 2 cos m theta plus n phi. Okay, and hence proved. So this is next very important question. Show that 1 plus I to the power n plus 1 minus I to the power n is equal to 2 to the power n by 2 plus 1 cos n pi by 2. This is very important question. Okay, so proof. Our aim is to calculate this left hand side. Okay, means 1 plus I to the power n plus 1 minus I to the power n. So we have in complex analysis any quantity a plus iv in polar form r cos theta plus I sin theta. So 1 plus I is equal to r cos theta plus I sin theta, because our aim is to change in de Moivre's theorem. So this is 1 plus I is equal to r cos theta plus I sin theta, and taking real and imaginary part. Okay, so r cos theta, this is real part, is equal to 1, and r sin theta, this is imaginary part, is equal to 1. Okay, means coefficient of phi is r sin theta, and here coefficient of phi is 1. Now we calculate value of r and theta. So here on squaring and then adding, means r square cos square theta plus sin square theta is equal to 1 square plus 1, means 2. Cos square theta plus sin square theta is equal to 1. So r square is equal to 2. It means r is equal to plus minus root 2 and taking plus sign. So by putting here, so tan theta is equal to, by dividing, is equal to 1, means theta is equal to pi by 4. So this can be written, means 1 plus I is equal to root 2 cos pi by 4 plus I sin pi by 4. Okay, and similarly 1 minus I is equal to root 2 cos pi by 4 minus I sin pi by 4. Okay, now 1 plus I to the power n. So now 1 plus I to the power n. So this is equal to, on taking nth power on both the sides. Okay, so we get root 2 cos pi by 4 plus I sin pi by 4 to the power n. So this equal to, this is 2 to the power half, means 2 to the power n by 2, because this is n, and this is cos pi by 4 plus I sin pi by 4 to the power n. By de Moivre's theorem, we have cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. So by using this de Moivre's theorem, this is equal to the power n by 2 cos n pi by 4 plus I sin n pi by 4. Okay. Similarly, 1 minus I to the power n means, similarly, 1 minus I to the power n, so this is equal to 2 to the power n by 2, only this term will negative. So cos n pi by 4 minus I sin n pi by 4. Okay, so by adding, this is 1 and this is 2. So by adding 1 and 2, 1 plus 2. So we get 1 plus I to the power n plus 1 minus I to the power n is equal to, so if we add, so 2 to the power n by 2 is common, and this is positive and this is negative. So this is this is 1 and this is 2. So 2 to the power n by 2 is common, and this is cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin n pi by 4. So this will cancel. This is 2 times, means 2 to the power n by 2 into 2 cos n pi by 4. So here 2 to the power n by 2, this is 1, means 2 to the power n by 2 plus 1 cos n pi by 4, and hence proved. Okay, so this is very important question.